Hi guys, welcome back, MCC. Recently I got this, the pure black coffee. And this is really kind of bitter. So usually we add this, like the sugar or something else, which is also sweet. But as the best chemist that ever lived, I choose to make it myself. And just from one thing that you usually see in the common life, that is the newspaper. So let's have a start. Since the old flask has been used to make so many things like sulfuric acid, nitric acid, and even the super toxic UDMH, which in my point of view is definitely not safe enough to make food. So I just ordered a new flask online for this. While unboxing the flask, I'm going to explain why making sugar from the newspaper is reasonable. It's all because that the main materials of the paper is cellulose, while the cellulose is the deployment of glucose, a kind of sugar. And if we exchange both sides of the equation, you can see that the cellulose just be broken down into glucose. To make this, what's needed is simply just some thin acid solution. Well, before we start up to reflect the paper in the acid solution, I have to mention a new concept, that is crystallinity index, CRL for short. This indicator reflects the strength of the combination between the fibers of the cellulose. Lower it is, easier it can be broken down by acid. The common CRL of the newspaper is usually around 0.4, and to decrease it, the best way is bathing the paper in the 85% phsophoric acid. Even though you'll find it entirely wrong later, but let's just see how I make this terrible fault. So here I just pour all the acid into a bunch of paper. It's unnecessary to worry about the acid corroding the iron point. Instead, the iron perceived will react with phosphoric acid to form iron phosphorate, a kind of insoluble salt. This thin but tight salt layer would protect the pot from being corroded again. After all the paper is pressed into the acid, the mixture is kept still for 1 week. The next week, I push all the mixture into the new flask, and then making half a liter of 10% sulfuric acid solution. Then pour the solution into the flask, and reflect the whole thing for 12 hours. Since I didn't have a sulfuric condenser at the time, I decided to use a straight condenser directly. It's also usable. Now that I've mentioned the selecting of the condensers, if you saw the condensers roughly, there are usually 4 types of condensers, which are called as straight condenser, spherical condenser, serpentine condenser, and a reflecting condenser. Among all of those, the best one for reflecting is obviously the reflecting condenser, because it has the biggest cooling superficial area. The second is spherical condenser. The third is straight condenser. The top 3 ranking are mostly determined by the size of the cooling surface. As for the last one, serpentine condenser, the reason for it to be the worst one is not that the cooling area is too small. Instead, it's all because that is too big, and the inner diameter of the cooling tube is too small, usually smaller than 1 centimeter. So it can be easily stocked by the liquefied vapor, and it would probably lead to a gush. That's really a disaster. But except this, there is a type of reflecting condenser which looks extremely similar to this, but they just work in an entirely opposite way. The water goes through the inner part, while the vapor goes through the outer part, which creates a huge volume for the vapor to liquefy and flow back into the container. And I think, in a way, this could be the best choice. After 12 hours of reflecting, what I have now is this super acid, dirt, but very sugary solution. And to separate the solution out, I use a filtering funnel to filter out all the solid fibers and wash the rest part with some pure water. And what I have now is some clean but acid and colored solution. So the next step is to neutralize the acid in it. In most cases, this would be done with some sodium carbonate or sodium hydroxide. But the sodium phosphorate and the sodium sulfate are both soluble. And this apparently means that the final product would probably be a bunch of salt instead of sugar. So I choose to use sodium hydroxide. Well, this time, the two new products are insoluble. I then add the calcium hydroxide into the mixture slowly and wait for it to be done. Well, here I have to say the words failed me when dealing with so much sugary but mud-like mixture, with a filtering funnel which has only 150 milliliters of volume. I spent nearly 2 weeks on this boring filtering work. It's really an awful experience. Well, after the filtering is done, the color of the solution is still strong. So the next step is just decolor it. To make this, what's needed is simply just some active carbon. The most difficult part of this step is also filtering out the used carbon, but not because the carbon is too much or too big. Instead, it's mostly because the fine ash of active carbon is not easy to filter out. So, besides using the filtering paper as well, to better keep all the ash out of the solution, I choose to use some kisagur, which is also a kind of fine ash, but it's not fine enough to get through the filter paper and can keep the carbon ash away. Even with a thin layer of this, can work pretty well. After getting the final sugar solution, though it is slightly colored, I still believe that the sugar I want is just in it. So I heat it up on the oven. So finally, I got these small, but I think really meaningful crystals. So here, let's back to the very beginning of this video. I finally make this, the sugar, and I'm just going to add it into this coffee. So here it's already been dissolved in this coffee. Let's have a try. Not bad. I mean, it is just kind of better. And I think basically I reached my goal. Okay, that's all. Well, that's not all for today's video. Actually, I'm very confused about why I use so much materials but only got that less sugar. This is unfair. After I reviewed the patents and articles, I found that things started on the wrong track from the very first step. The correct way to lower CLL is to dissolve cellulose in concentrated phosphoric acid. In this procedure, the hydrogen bond network of cellulose can transfer protons released by phosphorate ionization in a relay manner, and causing rapid protonization within cellulose aggregates to form cellulose polycations. This electrostatic repulsion disrupts the intermolecular hydrogen bond network structures of cellulose. So I just make 10 grams of newspaper and then add in about 200 grams and 50% phosphoric acid. Then keep it under room temperature for 2 days in order to separate the phosphoric acid solution of cellulose from those solid liquid mixtures. What's needed is filtering the solution out, and to make sure it's done, the rest part is washed with some clean acid again. And now, to regenerate the cellulose from the concentrated acid, the solution is slowly added into 2 liters of cold water on a strong stirring. After it's done, the cellulose doesn't appear immediately, and to make it appear, the solution must be neutralized. And this time, this should be done with sodium hydroxide, because the sodium salts are soluble, while the calcium isn't. At first, I think that a simple vacuum filtering can separate the cellulose out, but later found that the cellulose is just too fine at first, and can easily block the filtering paper to make the filtering terribly slow. And my solution to this is first put the cellulose for about 6 hours to make it recrystallize and precipitate, even though this would slightly increase the CLL of the cellulose. And then pure out the upper cleanly, and keep the lower cloudily, or you can extract the clean part out with a dropper. When the crystals are roughly dry, they are put in the filtering funnel to be fully dry. So finally, you can see those beautiful crystals. And now, to hydrolyze the cellulose, I make 300 liters of 10% sulfuric acid and then reflex for 6 hours. The things following are extremely similar to the last time. The acid is removed with calcium hydroxide, and I then filter the sugar solution out. The only thing different is that the solution is no longer needed to be decolored with active carbon or something else. And then you can see those sugar crystals. They are just the same as before, even cleaner. I believe this time the yield is much higher. I have this crystal now, and I'm just adding it in the coffee. And stir this until it is dissolved. It's already been dissolved in it, and let's have a try now. Pretty nice. The last time the coffee is too much, but this time is just proper. That's all for today's video. If you like more video about chemistry, please subscribe and hit the bell. See you next.